Good morning. Welcome to the Math Department, Amjad High School for grade 11. This chapter is on plane transformations, rotation. Let's start with an activity. Consider in the oriented plane the square ABCD, as you can see in the figure on the right, with center O and side AB 4. Compare the lengths AB and AD. For sure, AB is equal to AD since these are sides of a square. Determine a measure of the oriented angle AB-AD factor. A measure of this is positive pi over 2. We say a measure because you can say it's pi over 2 plus 2 pi. Or you can even say it's minus 3 pi over 2. So pi over 2 is a measure of this oriented angle. We denote by R the rotation of center A and whose angle is positive pi over 2. As you can see, we can say that since AB is equal to AD, and since the angle AD is equal to pi over 2 plus 2k pi, then we say that the image of B by the rotation of center A and angle pi over 2 is D. So D is nothing but the image of B by rotation with center A and angle pi over 2, as if you are taking from A the distance AB and you are rotating as if you are rotating the segment through an angle of pi over 2. Notation, we say that R of B is D. So we have rotated B with an angle of pi over 2 through the center A. B is called the pre-image of D by this rotation. Now let's calculate OC and OD. OC is equal to OD is equal to 2 radical 2. You can do it using Pythagoras, or you can say that the diagonal of a square is side radical 2. So each of OC and OD is half of a diagonal. Determine a measure of the oriented angle OD-OC. If you find this angle OD and you rotate OC, you will be going clockwise. And as you know, clockwise is a negative orientation. So that's minus pi over 2. Let R prime be the rotation with center O and angle negative pi over 2. We can say that since OD is equal to OC, so you have to keep the same distance. Since OD is equal to OC, as if you are using a compass where the needle is at O and the other extremity of the compass is at D. If you rotate, you will get, with an arc, you will get the point C if you rotate with an angle pi over 2 clockwise. And we say that C is the image of D by R prime, or simply R prime of D is C. D is called the pre-image of C under R prime or by R prime. In this chapter, we're talking about rotation. So we are rotating points or even figures. But to rotate, you need to use a center. Because if you use a different center, you will get the figure in a different place. The rotation is one type of transformations. It is the circular motion of an object around a fixed point. The fixed point, as in this figure here, the fixed point about which the object is rotated is called the center of rotation. The amount of rotation, whether measured in degrees or in radians, is called the angle of rotation. Rotations may be clockwise or anti-clockwise, depending on the angle, whether it's positive or negative. An object and its image by rotation have the same shape and the same size. So they are coinciding. You can let this figure to be coincident with that figure. But the figures may be turned in different direction. So each rotation is defined by a center and by an angle. The original object and the image are congruent. Image, let's now define rotation in a proper or in a formal way. Given a fixed point omega in the coordinate plane and a real number alpha, we call rotation with center omega and angle alpha the transformation that is denoted by r omega alpha. So these are the basic element of each rotation. For each rotation to be well defined, you should indicate its center and you should indicate the value of its angle. So this rotation is defined as the plane transformation that associates for any point m in the plane the unique point m prime such that omega m should be equal to omega m prime and the angle omega m prime should be equal to alpha. For example, if you want to rotate this point m through rotation with center omega and a certain angle alpha, whatever alpha is, so you have to do it like this. So as you can see, the distance OM is kept the same as if you're using a compass with the needle here at omega, but how much you have to rotate? You have to rotate alpha depending on how much alpha is. So omega m is equal to omega m prime. So we say that m prime is the image of m by this rotation, and we write r of m is m prime. Notice that the only point that coincides with its image is omega, because omega is the center, so the distance from omega to omega itself is 0. So the only point that is invariant that coincides with its image is the center of rotation. The center of rotation is said to be an invariant point. This m is not invariant because it has moved to this place or this new position. Similarly, you can observe the image of the point n. For example, if I'm using the same rotation with the same center and same angle, if I want to apply this rotation to n, I need to do it like this. So the image of n will be n prime. Omega n is equal to omega n prime, and the angle between the vectors omega n prime has to be alpha. Let's do an application. Given in the oriented plane a square ABCD with center O, M and P and Q are the respective midpoints of the sides, as you can see in the figure. Consider the rotation defined with center O and angle pi over 2. So it's very important here to know where the center is and the measure of the angle. What is the image of O by this rotation? Since O is the center, so you don't need to look at the figure even, and you don't need to look at the value of the angle. O is the center, then R of O is O. O is the only invariant point. What is the image of N? So if you want to rotate N by a rotation with center O, but with an angle positive pi over 2, it will be P, since ON is equal to OP, and the angle ON OP is pi over 2. What is the image of Q? If you want to rotate Q through O with an angle pi over 2, so OQ will be rotated from O, you will get the point M. Since OQ is equal to OM, and the angle OQ-OM is positive pi over 2. R of what is A? In other words, what is the pre-image of A? Which point, in case you rotate it, gives you A? What about the point D? OD is equal to OA, and the angle here is equal to pi over 2. Some students will start with OA, but will move with an angle which is opposite to this, which is minus pi over 2. So you can go back so that you know the pre-image. It's D. What is the pre-image of N? Again, if you go ON, if you rotate with an angle negative pi over 2, you will find the point M. So the image of M is N. Consider a different rotation now with center A. So we are changing the center. This is a completely different rotation. and whose angle is what? Minus pi over 2. Complete. What is the image of A? A is the center, so direct the image of A is A. What is the image of Q? If you rotate Q from A with an angle negative pi over 2, so you have to move it like this clockwise, it will be M, since AQ is equal to AM, and since the angle here is negative pi over 2. What is the pre-image of B? To find the pre-image of B, move it from A, but now move it pi over 2. It will be D. So R of D is B. Okay, let's continue now. Construct O prime, the image of O. If you want to rotate O through A with an angle which is negative pi over 2, you have to move clockwise. So it will be somewhere here, but you have to make sure that you keep the same distance. You can use the grid here. It's clear that the diagonal here, AO, or the half of the diagonal. So, and you have to construct M prime, also the image of M. Given the rotation now, R of center omega and angle alpha, M and N are two given points in the plane, as you can see. M prime and N prime are the images of M and N respectively. So if you want to rotate M, it will be like this, as we have explained in the previous slide. Now, also, if you want to rotate N, then it will become N prime. In each chapter of rotations, of transformations, whether translation or rotation, you have to find what we call the characteristic property. It's a relation between two original points, M and N, and their relation with their images. If you still remember in the previous chapter, the relation between the two original points, M, N, and their images, M prime, N prime, was Mn vector is equal to M prime, N prime vector. Is it the same here? Do you think that Mn vector is equal to M prime, N prime vector? So R of M is M prime and R of N is N prime. We notice that if you look at these two triangles, omega Mn and omega M prime, they are congruent. You can prove it easily. So the distance Mn is the same as the distance M prime, N prime. But do they have the same sense as vectors, or do they have the same direction even? No. There is an angle between the vector Mn and the angle vector Mn and the vector M prime, and that angle is nothing but the angle of rotation. So this is a basic property in transformation, in rotation. Whenever you have 2 points and their images, the relation will be the distance is equal and the angle between the vectors is the angle of rotation. What about image of a figure by rotation? Assume you are considering a rotation with center omega and angle minus pi over 4. Actually, to find the image of a figure, you have to rotate each single point on the figure. But actually, we cannot do all of this. It's enough to do the basic points, then you connect them because you are sure that the figure will be exactly the same. So if this is a right triangle, you know that the image will be a right triangle. So apply the rotation, but with an angle minus pi over 4. So you will get this figure. So the image of A will be A prime, the image of B, so omega B prime, the same distance. Omega C will be rotated with an angle minus pi over 4 to get C prime. Now, if you connect A prime, B prime, and C prime, you will get exactly the same geometric figure, a right triangle with the same area. So this angle is what? Minus pi over 4. Now, what is the image of a circle by rotation? The image of the circle must be a circle. It should have the same perimeter and the same distance. But how can we get it? Simply, you can find the image of the center O with this rotation with angle omega and angle 2 pi over 3. If you do that, so O prime here is the image of O, whereas the radius will be exactly the same. So actually, to find the image of a circle by rotation, it's enough to find the image of the center, and you keep the same radius. Rotation in this example is 2 pi over 3. So the image of this circle is that circle. Any point on this original circle must have its image on this new circle C prime. So C prime is the circle with center R O prime, which is the image of O under R, and same radius as C. Now, what do you think the image of a line by rotation? If you still remember, in translation, the image of a line was a line, which is with the same direction as the original line. But here you have what? You have a rotation. Let's consider two cases. The first case where the center belongs to the line, but the line must be rotated. How to rotate a line? It's enough to take 2 points on the line and to rotate them. So the image of A will be A prime, the image of B will be B prime. Do not forget the image of omega must be omega. So the image of the line D will be the line passing through A prime, B prime, and omega. Actually, to find the image of this line, since it's passing through omega, it's enough to find the image of one point, which is A, for example. And you know that omega is invariant, so it will be omega A prime. What about now a line which is not passing through the center? Again, the image of a line, you can consider 2 points, A and B. Find the image of A, and that's A prime. Find the image of B, and that's B prime. Now, the image of the line D will be the line passing through A prime, B prime. So, the image of a line is a line making an angle alpha with the original line. For sure, here you have to be careful because the angle between two lines, some students may consider this to be the angle. Actually, when we are solving exercises, we have to be careful about this. For example, if you know that the image of a line D is a line making an angle, let's say pi over 4 with the line D, actually there will be two lines making an angle pi over 4. So you have to be careful. We leave this when we're solving exercises. But the most safe way to find the image of a line is to consider 2 points on the line and find their images and connect them. So in general, the image of a line D is a line D prime making an angle alpha with the original line, and alpha is the angle of rotation. In general, rotation preserves everything, collinearity. So if ABC are collinear, then their images by the rotation must be collinear. It also preserves the midpoint and the center of gravity. So if I is the midpoint of the segment AB, then R of I must be the midpoint of the segment, which is image of the segment AB. If G, let's say, is the center of gravity of triangle ABC, then R of G must be the center of gravity of the image of the triangle ABC. Rotation also preserves parallelism. So if two lines are parallel, and you're finding the images of these two lines, then these two new lines must be parallel. Orthogonality, if two lines are perpendicular, then their images must also be perpendicular. Rotation preserves area, perimeter, and the shape of the figure. Actually, rotation preserves everything. You cannot find the image of circle and to get a larger circle. Like the image of a triangle with area 5 centimeters squared will be a triangle with area 5 centimeters squared. But you are changing the position of the triangle. One more application. Given in the oriented plane a rectangle ABCD, AB is 2 centimeters and AD is 4, I and J are the midpoints of AD and BC. Consider the rotation R with center I and angle pi over 2. Determine R of A. So to find the image of A, you have to rotate through I with an angle positive pi over 2. You will be at J, since IA is equal to IJ, and since the angle IA, IJ is equal to the angle of rotation. So R of A is J. Determine R of J. So if you want to rotate a J with the center I, remember again, as if there is a compass with you where the needle is at I and you are opening the compass at J and you're rotating with an angle pi over 2, you will get D, since Ij is equal to Id and Ij is equal to pi over 2. So R of J is D. Deduce R of B. So you don't need to construct the image of D. Here you can think of B as the fourth vertex of the square IABJ. But the image of I is I, and the image of A is J, and the image of J is D. But you know that the image of a square must be a square. So the image of B must be the fourth vertex of the square image. So let B prime in general be R of B. We know that R of I is I, R of A is J, R of B is B prime, let's say. R of J is D. But since IABJ is a direct square, then its image IJB prime D is also a direct square. But in the figure, C is that point because IJCD is a direct square, so consequently B prime is nothing but C. Therefore, the image of B is C. Deduce the nature of the triangle IBC. Since C is the image of B, and we have proven this by using that C is the fourth vertex of a square, then IB distance must be equal to IC distance, and the angle between IB and IC should be pi over 2. This is because we have proven in the previous part that the image of B is C, and consequently the triangle IBJ is right, isosceles at I. Thank you for this session.